Hello everybody and welcome to another Mystery Box Function Challenge. In the purple box, there's some mystery math and your challenge is to figure out what that is. You can try this out by using the link in the description, and when you've got an idea, come on back and see if we get the same thing. All right, let's start with a 0. Whoops, not an O, a 0. Okay, 0 gives us 2. How about a 1? So we've got what looks like a non-repeating decimal. So maybe a square root function, maybe trig. How about a 2? Okay. Not sure yet. How about a 3? Oh, okay. So it went down and then up, so maybe we're in the trig category. Let's put in a few more points. There's 4. How about a 5? Uh-huh. Okay. Let's put in a 1.5. So this is an approximation for pi over 2. Yeah, so that's right down at the low point there. And let's do some negative values. I'm going to do a negative 1.5. And maybe a negative 2. And a negative 3.14. Okay, so this definitely looks like sine or cosine. It's got that repeating waveform. So let's do some thinking about this. Something's been done to it. Clearly, it's up in the graph. So some number's been added to it. But it looks a little funny to me. So let's think about it together. So I'm going to draw a unit circle here, and remember with these functions of sine and cosine, we're putting in an angle, and we're getting out the coordinates where that angle intersects the circle, and then the x is the cosine and the y is the sine. So what have we got going on here? So at 0, we start here at 2. Actually, maybe we should think about whether there's a multiplier and how far this has been raised up off the the x-axis here. So when I look at when I think about a multiplier, what I do is I try to look at the amplitude, so how tall this thing is. And the lowest here is 1, and the highest, it looks like it's 3. So it looks to me like there's no multiplier, right? The regular sine or cosine function, goes up 1 and down to negative 1. This just been moved up, and it looks like it's been moved up by 2. So I think we've got, if we're going to start sketching our function here, we've got um, either the sine or the cosine of something, and then plus 2. So we'll leave a space there and put a plus 2. So I think that's been raised up to. Which function is it? So at 0, the 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 coordinate here is going to be 1, 0. On the x, we're out at 1, and on the y, we're at 0. So the sine starts at 0, and here we're starting at 2. That's the plus 2. So I'm thinking this is sine, but something looks a little funny here because the sine, the y coordinate, gets bigger and bigger and hits its biggest at pi over 2. And we're doing the opposite. We're getting smaller and hitting our smallest at pi over 2. And then the sine gets smaller and smaller and goes to 0 at pi. And here's 3, so that's very close to pi. We're back at this 2, which is sort of our 0 because we've added 2. So it looks like the sine at 0 and at pi, but it seems to be going in the opposite direction. So how would you achieve that? Well, I think you could do that by just putting in the negative sign of x. So we'll think about that for a second. If the sign is 0, it's not going to change it. And that's why it looks like sine at 0 and at pi. But if you, every other point, it's going to make it do the opposite thing. So instead of going up, it's going to go down. Instead of going down, it's going to go up. After pi, the y coordinate goes further down until it gets to its biggest negative here at pi over 2. And that we see here, except it's going up, which it would do if it had the negative sign. And this continues. I don't think there's anything funny on the other side here. It's the same form continuing. So I think this is probably the negative sine of x plus 2. I think I'm going to look. Let's take a gander. Yeah, there it is, the negative sine of x plus 2, and we can graph that as well. And that's your typical sine curve, just kind of flipped upside down and shifted up 2. Well, how did that go for you? I don't think that was a particularly easy one. Let me know. Thanks, everybody.